Alright, in this video here I'm going to continue an example that I started in another video where we're graphing this rational function 2x squared plus 7x minus 4 over x squared plus x minus 2. So if you didn't watch that other video where I started this problem, you should probably stop this here, watch that part 1 of this problem where I found the x and y intercepts and I found the horizontal asymptote, and I explained that stuff I think pretty well. I had enough time to explain that. But then when we got to the vertical asymptotes and actually sketching the graph, I had to go real fast through that stuff because I was running out of time on the video. So on this video here, I'm going to start again with the vertical asymptotes and just talk about that last part that we did, and then also talk a little bit more detail about actually sketching the graph. So if you watched that first video and you got to the point where we did the vertical asymptotes and it was like, well, that was just too fast and I don't understand it, I'll go a little slower here and I'll explain the stuff that we did at the end of that video, right? But again, if you haven't watched that first video yet, you should watch the beginning of it, at least until we get to the horizontal asymptotes, because I went through all those things and I explained how we got all this information here. All right, so to find the vertical asymptotes of a rational function, I set the denominator equal to 0. Now, I'd already factored the numerator and denominator, so when I'm looking for the vertical asymptotes, I use that factored form, x plus 2 times x minus 1 equals 0, and then I can just straight away separate the factors. X plus 2 equals 0 gives me x equals negative 2. X minus 1 equals 0. When I solve that, I get x equals 1. Right, so the graph of this function is going to have two vertical asymptotes, right? One at x equals 1, and the other one at x equals negative 2. Right, so that's going to give me two vertical asymptotes. What I need to do now, and you can see I have those over here on the side, those arrow things that I have there, the next thing I have to do is decide, well, what's going to happen on either side of that asymptote at x equals 1? Are both sides going up towards positive infinity? Are they both going down towards negative infinity? Is one up and one down? What's going on? Right, so that's where we have to do what we call test points on either side. All right, so that's, we found where the asymptotes are, but that's not the whole story when we're doing this type of thing. Right, now what we need to do is figure out what happens on either side of that asymptote. So I'll start with x equals 1. Right, and it doesn't matter which one of those two asymptotes you want to begin with. I'll take x equals 1 for no reason, really. So I need to pick a number a little bit on the left side of 1. So let me pick x equals 0.9. All right, this is on the left side. So left side talking about like when it's on the graph, if I have a vertical line at x equals 1, I need to pick a point a little bit to the left of that vertical line. So I'm going to pick 0.9. And then I have to pick a number a little bit on the right of that vertical line. So let me pick x equals 1.1. All right, so I pick a number just a little bit on either side of where I'm going to have this vertical asymptote going through my graph. Right, that dotted vertical line is going to be at x equals 1. I pick a number just a little bit on either side. Now, I want to pick a number close. Don't pick like x equals 2 or x equals 0. That's too far away. We need to pick a number really close to x equals 1. All right, so what I do with these numbers I pick, these are my test points. I take x equals 0.9 and I plug that into my function to see, well, is that going to give me a positive number or a negative number? If it gives me a positive number, that means that on this left side of the graph's going to go up positive towards positive infinity. If it gives me a negative number, that means on the left side of this line, the graph's going to be negative. It's going to be going down towards negative infinity. Right, so all I really care about here is when I plug in 0.9, does it give me a positive number or a negative number? All right, so to do this, I'm going to go ahead and use that factored form that we already have. Right, so my y value is going to equal 2 times 0.9 minus 1 times 0.9 plus 4 over 0.9 plus 2 times 0.9 minus 1. Right, so I go to my factored form for every one of those x's there, I put x equals 0.9. Right, and now, once again, all I'm concerned with is this going to give me a positive or a negative answer? Well, 2 times 0.9 minus 1, I don't need to know exactly what that equals, just is it a positive or a negative factor? If I do 2 times 0.9, that's going to be 1 point something, and when I subtract 1, that's still going to be positive. Right? It's going to be 0.8 if you're actually doing the calculations. It's going to be 0.8, but I don't care about 0.8. I only care that it's a positive number. Right? If I do 0.9 plus 4, well, obviously that's going to be a positive number. Right? It's going to be 4.9, which was a positive number. Right? 0.9 plus 2, well, that's going to be a positive number. 0.9 minus 1, that's going to be a negative number. Right? Because when I do 0.9 minus 1, I'm subtracting a bigger number from a smaller number. It's going to give me a negative answer. All right, so these are my factors. All I care about is each factor positive or negative. And then when I put it all together, well, positive times positive is going to be a positive number. positive times negative is going to be a negative. So I'm going to have a positive over a negative, which equals a negative result. Right, so overall, when I plug in 0.9, I'm going to get a negative number. Right now, if you have the ability and the time to actually do the calculation in either this form or that form and see what number it actually comes out to, that's great, but it's not necessary. Right, I just need to know, is it positive or negative? And since and let me actually write this down below so I have more room on this side here. Right, so this is actually going to give me a negative number, right, which tells me that when we're on the left side of this vertical asymptote at x equals 1, the number I get is negative, which means the graph is going downwards towards negative infinity. Right? So on the left side of that asymptote, y is going down towards negative infinity because I had a negative result here. All right, so that's what I'm doing when I'm testing my points. Which again, on that first video that I did, I put all this work up here and I just kind of real quick explained what was going on, but I didn't feel like that was enough of an explanation for people to actually understand what was happening, which is why I'm making this other video about it. Right, so that's what I do for the left side of 1, and then on the right side, I have to again go and do the same thing all over again. And like I said on the first video, finding the vertical asymptotes and figuring out how the graph goes is like the longest part of this whole process of graphing a rational function, and it's the biggest pain to do. It's really a lot of little things you have to do here. Right, so basically I have to do all this stuff again, but now plugging in 1.1 instead of 0.9. Right, because I know on the left side the graph is going to go down. Now we got to figure out what's going to go on the right side. Right, we can't just assume based on this. It's not always like one is up and one is down. Sometimes both sides go down. Sometimes both sides go up. So you do always have to check both sides, unfortunately. All right, so I do the same thing. Y equals, and I take x equals 1.1 and I plug it into my factored form. Right, so 2 times 1.1 minus 1 times 1.1 plus 4 over 1.1 plus 2 times 1.1 minus 1. All right, so for each of those factors there, I plug in x equals 1.1. And once again, all I care about is each factor positive or negative? All right, so 2 times 1.1 minus 1, that's going to be a positive number. 1.1 plus 4, that's going to be a positive number. 1.1 plus 2, that's going to be positive. 1.1 minus 1, this time that factor is going to be positive. Right, so you can see only one of the factors changed when I switched my number, and it was that one on the bottom right. Right, that one changed from negative to positive because that's the factor that gave us x equals 1. Right, so that's the only one that's really affected when I pick a number on either side of x equals 1. All right, and then we can see what I have here is positive times positive, so that's a positive number, over a positive times a positive, which is also positive, and a positive number divided by a positive number is going to be a positive number, right? So to figure out whether this is positive or negative, I just use the rules of working with integers. When I multiply a positive times a negative, that gives me a negative answer. When I do a positive number divided by a negative number, that gives me a negative, right? If everything is positive that I'm multiplying and dividing, well, then the answer is going to be positive. All right, which tells me that on the right side of x equals 1, since I end up with a positive value, the graph is going up towards positive infinity. Right, so on this side of the asymptote, the graph is going to be going upwards, right, which is what I wrote over here underneath this x equals 1, where I was keeping tabs of all the information we found from that first video. At x equals 1, I drew that asymptote. On the left side it's going down, on the right side it's going up. Right, so that's how we test our vertical asymptotes to see which direction the graph is going on either side. And it's important to do that when you want to sketch a rational function, because otherwise you don't really know which direction it's going to go. Right, now, the really unfortunate thing is that we have a second vertical asymptote at x equals negative 2, which means I have to go ahead and do this exact same thing, but with negative 2. Right, so I have to choose a number a little bit to the left of negative 2, a number a little bit to the right, plug all those in, do all the same stuff to figure out which direction that one's going. And that's where I said that this can be a little bit of a painstaking process. It really gets bogged down here in all this little work you have to do. And this is only with 2 asymptotes. Some rational functions have 3 asymptotes, which means you would have to do this stuff 3 times. Right? Actually 6 times, because for each asymptote, you have to plug in 2 different numbers. Right? So I'm not going to go ahead and do that. I already did the work on that just to see what it comes out to. So you can see for x equals negative 2, the left side is going to go down, the right side is going to go up, just like what happened with x equals 1. If you want to practice that just to make sure, or to like double check, or to make sure you can do it, that's what it should come out to. So if you want to just pause the video here and kind of do what I did here, but choose x equals negative 2 instead, and then a number on the left would be like negative 2.1. A number on the right side would be like negative 1.9, right? Those are numbers on either side of negative 2. And plug those numbers in here and see, positives and negatives, what does it work out to? the left side should come out negative, so it goes downward. The right side should come out positive, so it goes upward. So I would encourage you to check that out and see if you actually do get those results. All right, what I'm going to do now is pause this recording real quick and erase all this work I did, and then I'll put up like the coordinate plane so that we can actually sketch the graph now with this rational function, and I can explain in a little more detail how to actually sketch the graph. All right, so I erased all the work I did for that vertical asymptote at x equals 1, and here's a coordinate plane that we're going to use now to actually graph this function. So on the first video that I did of this problem, I kind of drew the graph up here real fast and just real quick talk through it, but now I'm going to take it a little slower. So if you watch that one, you're like, well, I didn't catch what he did with that graph. I'm going to explain it here, so hopefully you're still watching it. So all the work that we did on the first video and then here on this second one, I'm just going to put all that information on the graph and then just basically connect it all and draw the graph. So my x-intercepts were at x equals 1/2, which is right about there, and x equals -4, 1, 2, 3, 4. So there's my 2 points for my x-intercepts. I can just put those points on the graph. My y-intercept was at y equals 2, so that's going to be up there. All right, next up, I have a horizontal asymptote at y equals 2. All right, so you might see that, you might think, well, something's wrong here because the asymptote, the graph is not supposed to touch the asymptote, but the y-intercept is right on that horizontal asymptote. Remember, a graph can cross a horizontal asymptote. The horizontal asymptote is only telling us what's going on way off on the right as x approaches infinity, or way off on the left as x approaches negative infinity, right? So that horizontal asymptote at y equals 2 means as we go way off here, the graph's going to get closer and closer to that horizontal line. I don't know which direction it's going to come from yet. And on the left side, it's also going to get closer and closer to that line from one direction or the other. But in the middle here, for finite x values, you are allowed to cross that asymptote, right? So don't think, well, the graph looks like it's going to hit that asymptote, I must have done something wrong. That is allowed, right? The graph can cross or touch a horizontal asymptote. The graph cannot touch, though, a vertical asymptote. All right, so that's the one that you're not allowed to cross that line at all. All right, so my vertical asymptotes are at -2. So at x equals -2, let me draw that vertical line. And then at x equals 1, so at x equals +1, let me draw another vertical line. All right, so I got my asymptotes, I got all my intercepts on the graph. Now what we need to do, and this is why it was important that we did that work that we did earlier in this video, I need to now know the behavior near my asymptotes. So for the asymptote at x equals -2, the left side is going down towards negative infinity. All right, so it's important to know that so that I can connect that to the rest of the graph. And then the right side should be going up towards positive infinity. All right, so I can just kind of draw those arrows there on either side of my asymptote at -2. And then the same thing for -1. At x equals -1, on the left side, the graph is going down. So let me put an arrow down there pointing down. And on the right side, the graph is going up, so I put an arrow over there going up. Right? Really important to know that, otherwise you don't really know what's going on in between these asymptotes. You know, on this side, is it down this way or is it up this way? I don't know unless I actually plug in that point of 1.1 and see that I get a positive number, and so I know the graph is going up. Right? That's why that stuff we did earlier, even though it was a real pain and it took a lot of time, it is important to do all that stuff so you know which direction your graph is going. Right, and now what I need to do is draw this graph, and it looks like this graph is going to be split into 3 separate sections. Because of those 2 vertical asymptotes, that splits our coordinate plane into 3 separate parts. So on the left side, I know that the asymptote is down here. I have an x-intercept up here, so this graph is going to come up and hit that x-intercept, and then it's going to curve up here and approach that horizontal asymptote as I go off towards negative infinity. All right, so there's the first section of my graph. The second section of my graph is in between the 2 asymptotes. Well, up here, the graph is up high. It's going to come down and hit the y-intercept, hit the x-intercept, and then connect down here to the arrow that's going downwards. All right? And then my third section, well, up here, on this side of the asymptote, the graph is going up. So it's just going to curve down, and then it's going to approach that horizontal asymptote over there as x approaches infinity. That's going to keep getting closer and closer to y equals 2. All right, so that is what the graph of this function will look like. Again, you have to get all that information in order to get an accurate picture of the graph. The x and y intercepts, which I explained that on the first video for this problem, the horizontal asymptote, which I also explained on the first video, and then the vertical asymptotes and the behavior on either side, which we talked about in this video here. You put all that together and you get your graph of your rational function. It's a lot of work, but it's a beautiful graph, so it's worth it.